people do it, but it's a very bad idea, and you'll notice that the more experienced programmers don't tend to do that. So make sure that if you do start contributing patches, particularly when you're starting out, but really at all times, make sure that you thoroughly test the code before submitting it. Very important. Okay, so a bit more on the development model. There's a very strong emphasis on code quality, on the code being good code. And this is something it's very hard to put a handle on what is good code. It's code that gives you a warm feeling inside when you read it. It's code that makes one feel happy and joyous. That's good code. When the structure is nice, and that's good code. Some people, when they contribute code, they say the code works, accept it. And the code working, well, it's good that the code works, but it is not the most important factor in accepting code. In fact, the role of a project leader, I'm the project leader of a few projects, and in many ways my role is to reject code. My role is to say no, and say that's not good enough. And the number one principle that is used to reject code is maintainability. How easy is it to maintain that code? Is that code going to be a burden on us from the next 10 years, or is that code going to improve the maintainability of our core code? And we balance that with the feature that is being added. So you need to make sure that when you write code, you try to not just make it work, but make it elegant and simple. Complexity is bad. You need to make code as simple as you can while achieving the goal. One common thing that people try to do when they're starting out in free software is they over-engineer. When they write a piece of code, they think, maybe we might want to do that later. Maybe we might want to do this later. So they put in lots of extra code for things that you might want to do at a later date. And that makes the code much more complex. It is better instead to write code that just does what you need to do now, simple code, and if you need the additional features later, then extend it. So the code ends up simpler and easier to test. And you'll see the more experienced programmers will be rejecting just-in-case code. Just-in-case code is usually wasted code. Not always. There's some cases where you have to judge and you know you're going to be going down a particular path and it's worth doing. So you want to aim your code for elegance and simplicity and above all, ease of maintenance. Another common theme in the free software world is what's called refactoring. And that's a term that I think came out of the extreme programming world, where there's this theory of programming called extreme programming. One of its features is that programmers sit next to each other and something like that. That doesn't really tend to work in the free software world because often the people are on the opposite side of the planet and it's hard to rub shoulders at that distance, so you sort of use other mechanisms for code review. But the refactoring idea of changing the structure of the code to make it cleaner while not changing its functionality is an important theme, and you'll notice this happening all the time in major projects, and that's why the code remains maintainable, particularly when a new development theme, a new paradigm is introduced into the code. Maybe some new memory allocation technique, maybe a new database technique, some new API is introduced, and that new technique slowly filters its way through the code. So it starts in just one place, then over months or years it starts filtering into other places in the code. That's refactoring in action. It's often quite a slow process, but it's important so that you don't end up with lumps of old, hairy code that just stay static and really are just disasters waiting to happen. In order to do refactoring, this again brings up automated testing, because if you're doing refactoring, then of course you are removing code that has been tested, so it's essential that you have an automated test suite that covers the code so that when you refactor it, you can ensure that you have got it right. Otherwise, you lose all that testing time. Another aspect of open source development that I think is quite interesting is that it tends to be very long-term and but fast, which seems contradictory. So very often when somebody changes company in the commercial software world, usually they change which project they are working on. They have to abandon their previous project, they move to a new project, and they can't take the code with them. And people change jobs quite often. Certainly in Australia and the United States and Europe, people commonly change jobs every couple of years. Very, very common. I don't know if it's just as common here or not. When people change jobs, if they then change which code they're working on, they never have more than a couple of years experience at maximum with the code. Even when they're within one company, they might move between projects and thus have to start again on a new project. In the free software world, it's quite common for people to work on the same code for 10, 15 years, very long periods of time, and they get deep understanding of the code, or sometimes deep hatred of the code, if the code is bad, in which case they might be motivated to rewrite the code. But that's an unusual feature, so if you do want to get involved with an open source project, you need to understand that many of the other developers are developing on very long timescales, and you may sometimes be frustrated that your patch doesn't go in immediately, or the structure, you want this structural change, but it doesn't happen then, it happens at some later date. You need to understand that the timescales can be quite long. You need to be prepared to put in long-term, many years of effort, not necessarily full-time, of course, just, you can part-time or when you can, but often over a very long period. At the same time, development can sometimes be very fast. An extreme example of that is the Linux kernel, where patch sets, sometimes there's 2 new revisions in one day. Extremely fast development. The Samba is a bit slower than that, but still quite fast. Some projects are very slow, those that tend to have been around for a long time and not need new features. They sometimes develop more slowly. So there's this contrast of very fast development but long-term development. So what I wanted to talk about next, and I should point out, by the way, that I haven't had any questions yet, which is really rather disappointing. Either you haven't understood anything I've said, or you're a very boring audience. So think of some questions, much more interesting. Diversions are good. So I wanted to talk a bit about systems programming. Now, systems programming is where you are programming the nuts and bolts of a system. So typically it's either in kernel programming or something closely related to the kernel. We are talking directly to operating system interfaces, and you are dealing with memory management, file system management issues at a low level. This is quite different from application programming or GUI programming, different type of approach. So most of the work that I do is systems programming, and sometimes people ask me, how do I become a systems programmer? And so I thought I might as well tell you, and maybe 1 or 2 people here might decide to become system programmers. So these are the important steps I think you need to take to become a systems programmer. And I'll cover these steps in a bit more detail in the following slides. You need to learn the tools you're going to use in great detail. I think a good idea is to build clones of common system tools like LS and CP. You need to read books on operating systems internals, and you do need to learn C for systems programming. You might not use it necessarily in your systems programming. It is possible to do systems programming in other languages, but unless you understand C, you won't understand the interfaces into the operating system, which are usually C-defined.